comparing your p-value and alpha. I'm the researcher. I'm setting my alpha at 5%. Now, I go and collect my data, and I find that my value sits way down here. This is where my data is sitting. So I look in my table on page 407, and I find this area. What's the chance that that data would occur if this is what my null hypothesis looked like? Pretty unlikely. And in fact, I use my table, and I find this space or area to be happening 0.0019. It really doesn't matter what that data value is for my evidence, but I find that it's only going to happen less than 1% of the time. That's pretty unlikely. In fact, it's very unlikely. Comparing this value, which now we're going to call probability or p-value, to alpha. Well, it's less than. This value, 19/100%, is less than 5%. This was my cutoff for likeliness. This was very unlikely, so this would cause me to reject. Same scenario. I take a sample, and I find my value to land in this area. I use my table, and I calculate where is that value in terms of probability. In terms of probability, this value is a little bit more likely. The area of unlikeliness is looking at how much space is in here. Well, it looks to be less than 50%. Let's just suppose it's 35%. This value, or any more extreme, is going to happen 35% of the time. So when I compare the p-value of 35%, it is greater than 5%. It's likely, and in fact, it's so likely that I'm going to accept. This data actually supported my null. So when I'm looking at a p-value, I'm finding its unlikeliness. How do I do that? It's a probability. Those probabilities go back to page 407. Let's try another one. I'm going to, as a researcher, I'm going to set my alpha level to be at 10%. That's deemed unlikely. I'm looking on my curve. I go get some evidence, and I find my evidence to land down here in the tail. So checking this area, I find that area to be 6%. It's pretty unlikely. Is it unlikely enough? This was my cutoff. Is it unlikely enough? Yes, it is. 6% is less than 10%. It's unlikely enough, so that is telling me to reject my null. Let's suppose I go and get some data, and let's move it up a little bit. And let's suppose it fits right here. I go and calculate the probability of getting that, or any more extreme, and I find this new probability to be 20%. 20% is unlikely, but is it unlikely enough to go through all the hassle of making a change by rejecting my null? Comparing my p-value, which is 20%. It came from probability, looking at the page 407. Compare that p-value to my alpha. This is greater than 10%, so it's not unlikely enough, so therefore I need to accept my null. So what you're doing with a p-value and an alpha is you're comparing them. The alpha is the marker. It is telling me when to accept and reject. How unlikely does my data need to be before I reject? It needs to be 10% unlikely or less. 20% unlikely, that's not too bad. It's not low enough to reject, so I must accept my null. This will be working you into Chapter 10. You are not necessarily finding p-values in Chapter 1. You're comparing p-values to alpha. If your p-value is less than alpha, it is saying it's very unlikely, reject the null. If your p-value is greater than alpha, it is telling you that it's not unlikely enough to reject. If your p-value is equal to your alpha, it's telling you to reject. It's right at that border in which you're going to make that decision.